In assuming that a processor can work out the dependency graph across iterations of a loop, it turns out we're assuming that it solves a hard problem related to branches. So let's look again at our 2 by 2 unrolling with integer plus. Remember, we got a cycles per element value in that case of 0.81. In particular, that's less than one cycle per element. If we look at the machine code, then we see some additions and a comparison and a jump. These additions are independent, all three of these first ones. Um, so the processor can clearly discover that and do them at the same time. That's not too hard to imagine. But it looks like we need this addition to complete and then the comparison to complete before we can perform the jump. The addition and the comparison are both one cycle operations, so that's two cycles total. We are handling two elements, so that's only one cycle per element, but still that's too much to get down to a CPE below 1. That one cycle can be overlapped with the next iteration's arithmetic, but there's a problem with this delay of 1 to perform the actual jump. Right? And the answer is that the processor is going to guess about the jump. It's going to predict that the branch is taken and assume that it can do that work and start it going in parallel. And then it'll have to double check its guess before it exposes the fact that it made such a guess. Right? So the processor is going to make that guess by watching previous iterations of the loop and noticing that it keeps jumping. And then it can do the work in parallel, and it's going to keep the work internal and not push it out to memory or to the registers that you see until it's sure that that work needs to be done. So let's look at the example here. That's the important part of the loop here. Let's suppose we're on the I equals 0 iteration. Then what happens is the processor does some of this work in parallel, but not all of it. And eventually it sees there's a branch, and it waits around and finds that the branch is taken. And at this point, depending on the heuristics inside the processor, it might start to think that this jump is always going to be taken, because it is taken for the first couple of iterations. And after enough iterations, the processor will certainly predict that the branch is going to be taken in future iterations. Let's suppose that the length is 100 and we get down near the end of the input array. So at I equals 96, the processor has certainly got the idea. It's assuming the branch is taken. I is 98. It's going to keep going. It assumes the branch is taken. It's going to assume the branch is taken. But these last two should not actually have been taken. But it may get this far unrolling the loop and starting things in parallel before it discovers the problem. Discovers the problem being that the branch is not actually taken. So when this happens, the processor has to keep track of what its assumptions were and when those assumptions are incorrect, and it has to invalidate all of the work, give up the work, stop the pipeline, um, throw away the results, make sure they don't end up in registers or in memory, and then spend some more cycles to reload the pipeline on whatever branch was actually taken. Right? So there's a substantial penalty when the branch prediction is wrong, and the good news is that mostly it's right. Mostly branch prediction just works for the programs that you write, and there's not much you can do that'll make it better or worse these days. In the old days, there were some annotations and so on that could help, but pretty much it just works on its own. Um, if you are writing assembly code, there are things you can avoid, like not matching up call and returns. Is very bad for the branch predictor. From a C level, it's hard to imagine how they could not be matched up because a function call always returns eventually, but at an assembly level, you could confuse the branch predictor. At the C level, about all you can do is just not make random jumps, not make random branches. If your program inherently involves randomly branching, then that's too bad, but if it doesn't, then avoid doing that kind of thing.